The next section in your notes is about limiting reactant problems. For your limiting reactant problems, we're going to put it into a couple real-world explanations first. So with your real-world explanations, let's think about a car. And, okay, I won the lottery. I didn't really, that's really not where I'm at today. But let's pretend like I won the lottery. And so I take you all to a junkyard that is filled with cars. And I want to buy as many cars as they have that's complete that we could drive home today. So when we get to that car lot, they have 27 cars, but they don't have any tires on them. And then he said, oh, in the shed I've got 55 tires, and those tires are going to magically fit on those cars. So we need to figure out how many complete cars we can actually drive away with today. With my car bodies, I could make 27. With my tires, 4 tires will fit on each car, so that means that we have about 13 cars, and then we're going to have a couple extra tires, but 13 cars worth of tires that we can put together. So I have 27 cars without tires, I have 13 basically cars worth of tires. So what we can actually do is we can only make 13 complete cars that we could actually drive away with today. We're going to have an excess of cars. So if we found more tires, we'd be able to put together more cars. But I'm going to run out of my tires first. Limiting reactant problems work the same way. That we're going to have 2 different reactants and we're going to run out of one thing before the other. Now I'm going to put it in terms of another example. We like food, so we're going to use food for this one. Let's say that you are starving when you go home from school today. And when you go home from school today, you want a grilled cheese sandwich. Each grilled cheese sandwich is going to take 1 piece of cheese and 2 slices of bread. So you go to the refrigerator and you assess the situation that's in your refrigerator. And in your refrigerator, you have 5 pieces of cheese and you have 2 loaves of bread. So with those 5 pieces of cheese and 2 loaves of bread, if each loaf has, let's say, 20 pieces of bread, you've got 40 pieces of bread. With your cheese, you can only make 5 sandwiches. But with your 2 loaves of bread, you can make a lot more. You can actually make 20 sandwiches. So you are limited by putting your bread and cheese together by your cheese. You're going to run out of that first. You're going to have extra bread. So if your mom comes home from work and she says, oh, I bought more cheese, do you want another sandwich? You'd be able to put some more together. So with your limiting reactants, one of your reactants is going to run out. The other one is going to be in excess. So with your limiting reactant problems, it's finding out which reactant is used up first in a problem. If you need to write that down, you might want to pause the video for a second, write down this in your notes, and then go on when you're ready. Now, if we have something that is in excess, that was like our bread or our car bodies. That means that we have extra of it, that we're not going to run out. So you have your limiting reactant is what you run out of. Your excess is what you have extra of. So what you're going to do for these problems is now we have 2 stoichiometry problems to do. In your questions, you're going to see 2 different amounts. Both of those amounts are going to be in grams, and they're going to both be reactants. You're going to do a gram to gram problem with both of the problems, or both of the numbers given. So you're going to take your number of grams given, figure out how many grams of product you can make on both of them. So you have 2 stoic problems to do, not just one, but both of them are gram to gram. Now just to remind you, to go from grams to moles, you're going to use your molar mass. To go from moles of one thing to moles of another thing, you're going to use your mole ratio. Then to go from moles to grams again of your unknown, you're going to use your molar mass of your unknown. So you're going to do the same general process over and over and over. Grams to moles by using your molar mass, moles to moles by using your mole ratio. So you have to balance your equation. and then moles to grams of your unknown by using your molar mass. So like I said, you're going to set up and you're going to do a gram to gram problem. And you want to know how many grams of product you can make. Now, with the limiting reactant problems, sometimes there's 2 products to choose from. If there's 2 products to choose from, it doesn't matter which one you choose, unless the question tells you specifically, use this product. So you're going to pick one and you're going to stick with it through the whole problem. So like on the example problem that we're going to do in the next video, you have 2 grams of ammonia mixing with 4 grams of oxygen. So I have this and this. I want to know what is my limiting reactant. So which reactant's going to get used up first? You're going to pick either nitrogen monoxide or water. It doesn't matter which one you choose, but if you choose nitrogen monoxide, you're going to use that for ammonia and for oxygen. So you're going to go grams of NH3 to grams of nitrogen monoxide. You'll do grams of oxygen and figure out how many grams of nitrogen monoxide that you can make. Or if you choose water, you can fill in water there. But in either case, you have 2 gram to gram problems, one going from grams of ammonia to grams of product, grams of oxygen to grams of product. Now when you do the math problem, and I explain this in the next video, if it says what is the limiting reactant, you're going to pick the reactant. So the word reactant or compound reactant that you make the least amount of product. So which one are you limited by whenever you are doing the problems? If we go back to the cars, we had 27 cars and 13 cars worth of tires. We were limited by our tires. We had extra of your cars. So my limiting reactant for the math problem was my tires. With your reactants, there's 2 different ways of getting your answer. If the question says, what is the limiting reactant? Your answer, you're going to put down like limiting reactant, or you can write LR, is, and then give the actual compound for an answer. But if it says how much, you're going to have an answer in grams. The answer in grams that you choose from for your 2 different math problems is going to be the lower of the 2 amounts. So you have 2 options. You can either, if the question says what is the limiting reactant, you're going to write down a compound. Or if it says how much, you need to tell how much in grams. So you're going to pick the lower of the 2 masses from your math problem. So you'll have 2 masses to choose. Whichever one is less, that's the one you'll choose. So as we're going through a chemical reaction, the reason why a chemical reaction is going to eventually stop is because one of the reactants gets used up. So if you're burning a candle and you have that little candle burning in the classroom, and as that little candle's burning in the classroom, it's combusting the oxygen with the wax that's in the candle. And as that wax combusts with your oxygen that's in the air, you're going to run out of either wax or oxygen, which if it's in an open environment, all of the wax is going to end up disappearing. You're going to have extra oxygen in the air. So my limiting reactant is going to be my wax. My oxygen is excess. So that chemical reaction is going to stop burning whenever we run out of wax. Hopefully that clarifies everything. The sub does have a copy of the notes that have all of these little things on it if you need to copy it down if you didn't pause it throughout the video. The next video is called Dr. Gable Explains Limiting Reactants, and I'm going to do the 2 example problems that are in the back of your notes. So hopefully you're going to watch that video next, and that's going to help you to figure out that next problem. If you have questions, bring them back on Friday. And on Friday, I'll take your questions on limiting reactants, and then we'll go on to percent yield. Have a great day, guys. I miss you so much.